Aren't electric motors amazing? You put electricity in, and off they go. Using the motor effect, they turn the electrical current running through that coil of wire into an electromagnet, which pushes against these fixed magnets, which creates the motion. It's so good. But did you know this? The motor has a secret second use. You see, if I actually take away its source of electricity, you might think, well, that's it now. It's stranded. There's nothing it can do. What I'm going to do is I'm just going to attach the motor to a hand winding wheel here so that I can physically wind the motor myself. And instead of drawing power from the mains, I'm going to plug it into a voltmeter so that we can see exactly what this motor is doing. What you can see is if instead of putting electricity in and getting motion out, if I put the motion in, look at this. I am getting a detection on the voltmeter. If I put the motion in, I get a voltage out. A motor works as a generator if you change the input action. So you might be curious, why? Why does it act as a generator? Well, it's because of electromagnetic induction. With electromagnetic induction, if I moved a wire past a magnet so that the magnetic field lines cut across the wire, then I had a voltage induced in that wire. Now I've got a coil of wire here and I'm repeatedly moving it past the magnetic field of this fixed magnet at the top. And it is having the effect of pushing the electrons in here, or at least giving them enough voltage to register on this little voltmeter. In fact, I can actually turn this so much that I can actually start to get enough voltage to light up a light bulb. Whew. It means that the design of a generator is almost exactly the same as the design of a motor. A set of magnets on the outside and a coil in the middle that can rotate freely. Now what we would do with this is we try to attach it to something that is naturally rotating. A turbine, for example, is a really good option. Whether or not it is a wind turbine that catches the wind and rotates this central part of the generator, or whether or not it's a steam turbine in a coal or a nuclear power station, if you can turn that central coil of a generator, you will create a voltage that can go and power houses and cities and towns. Look at this. It's a generator, and I've attached it to a motor. And what I'm going to do is, I'm going to turn the handle on the generator, and then I'm going to have an energy transfer occur, where the mechanical energy is going to transfer through the wires as electrical energy before being turned back into mechanical energy on the other side. Are you ready? Watch the handle at the bottom. Look at it go! But what is interesting is one whole revolution of this handle produces about half a revolution of that one. Why is it? Energy losses. Did you hear the sound? Listen again. There's a whole load of energy being lost to sound and probably heat as well. The DC motor was not the only device that utilised the motor effect, for the electric speaker did also. If you remember, an alternating voltage was powered through these two wires into an electromagnet attached to the speaker cone. This would then alternately repel and attract towards the permanent magnet at the back of the speaker, shoving the speaker forward and backwards. So what we put in was the electricity and we got motion out. That's the motor effect. But if we press the speaker cone, then what that's going to do is it's going to push that wire back forward through the magnetic field of the permanent magnet, inducing an electrical current through these wires that we could detect. Here is a speaker. And it has a coil of wire just inside there. It's called a moving coil speaker. It's exactly the same as the speaker that would produce sound. But what I'm going to do is I'm going to start shouting at it, and the pressure waves from my voice are going to cause this to vibrate. And you can see the slightest vibration is detected as an electrical signal when electromagnetic induction inducts in that coil a very, very small voltage. So I'm going to shout at this, and hopefully what we're going to see is that this speaker doubles as a microphone. It works, look! Isn't that amazing? Microphones and speakers are the same device, principally. One of them works through the motor effect, and one of them works through electromagnetic induction.